Thank you for the invitation. Um, Sorry, first of all, I have been feeling unwell during the last week, and you can see my throat now, how it feels. So I'm not very enthusiastic, but I'll try to be as enthusiastic as possible. I have almost 40 slides. I'm going to try to cover all of them very quickly. I'm given only 20 minutes for presentation, correct?
It can be extended to half an hour. I'll give you some
Okay, great, thank you.
reminder.
Okay, so the idea to be able to understand generative AI is to understand all AI and to be able to put where generative AI is placed and also think about what will come in the years after, because AI as computer science is evolving every day, every month, every second. So first of all, be sure that generative AI will stop one day. It's not the end of the day. It's only one step in the evolution of AI. Okay, so I believe in this because I started AI 30 years ago, and the changes we have witnessed, it's you can't imagine. So be sure that next year, in 5 years, LLM would be something very old, right? Okay. So what I propose in terms of outline, I'm gonna talk about AI. What is AI, first of all, to be able to place where LLM is. Because to be honest, let me give you my, it's good, but I'm against it, okay? Just to open the discussion about it. So what are the different existing approaches in AI? We don't have only one, we have different approaches, and we're gonna see what are the pros and cons of the existing LLMs. And I'm gonna focus about a specific language, that's my mother tongue, but it's nice to have a sort of background. Why LLMs now? Why ChatGPT is good? And is it good in all languages or is it good only in English language? Okay, I'm taking it as only as an example, but you can adapt it to any in the other language. By chance, do you know how many languages exist on Earth? Thousands. We don't have only the English language, we have thousands of languages around the world. We have in terms of inclusivity, in terms of balance, in terms of different ethical principles, we should take into account these different languages to be able to talk, to exchange, to share the knowledge with all human beings around the world. And finally, I'm going to talk about the ethical side. You know, there is some ethical issues with LLMs, etc. So that's the starting point of AI. In 1956, in Dartmouth College in the US, these guys, with some other very known guys, John McCarthy, Claude Shannon, these are old ones, but those were the pioneers of AI. At that time, what was existing, only computer science. No one was talking about AI. And it is during this workshop that they decided they wanted to have a flashy word. That's why they invented artificial intelligence. And you see, it's still a flashy word when you talk about someone. I'm doing AI. Wow. But it's still, I mean, their selection of this expression, AI, was correctly chosen. So, as you can see, at the same time, we think that a significant advance can be made if we work on together for summer. So they wanted to, because before this, what was the strengths of computer science? If you compare it to anything done manually, computer science was an advance of something that can be done very quickly, right, accurately, but no intelligence. The machine was at that time still stupid. So can we add something else in addition to quickness and accuracy? They wanted to have intelligence, okay? So that was the starting point. What is important in all this slide is the last one. Today, we don't have only one definition of what is AI. As I just mentioned, the main definition of AI is to be able to simulate human intelligence using machines, okay? It could be something very simple, like doing, for instance, 1 + 1 = 2. Do you think it's intelligent or not? 1 plus 1 equals to 2. Think about it. Is it intelligent or not? Sorry? Very intelligent. Thank you so much. I do agree with you. If you take a baby, very intelligent. Now it seems to be very basic. Now it's not. Right? Let me give you another. If I take this chair, suppose I'm a robot, a stupid robot. I have a camera, right? And I walk. As a robot, what do I see in front of me with a camera? Do I know there is a chair? No, for me it's only pixels, right? But I don't differentiate that the color gray here is different from the green I can see here. And this is a sort of shape of something that I have to bypass. So a very simple baby, what it will do if walking, it will grasp here. While a simple and stupid robot, what will it do? Walking. Yeah, correct or not? So this is why we call it intelligence. Now with current AI, we could bypass it, of course, but years ago it was not possible to do it, right? So we would like to simulate intelligence. So that's why the main important thing in AI is how do you define intelligence? It's a philosophical. No one will give you, it's not QI, you know, it's QI, or IQ, sorry, intellectual quotient, something like this. It's not the case. It's more than this. Unfortunately, we have no exact definition about what is intelligence or human intelligence. But all what we do as human being, and the machine can do it, we consider the machine is intelligent, right? Now, you can see you have different definitions of AI today. Acting rationally. I'm going to explain all of this. Let me give you examples. You know, Alan Turing Institute, yeah? So one of the first pioneers in UK was Alan Turing, and he imagined years ago that a sort of test that he called the Turing test. You have two human beings, no, sorry, you have only one human being separated with a wall here and interacting. Today it seems obvious, but you can imagine in the 50s what it was. Interacting with someone, with supposed a human being, while it's an AI machine. So they send emails, they chat, whatever, until this guy and understands that behind it's not a human being, it's a machine. Okay? So how long means how intelligent is this AI program? Understand? So now today we can do it with ChatGPT. We know behind it's not a human being. Seems obvious, but this is, we would like to understand what is intelligence. This is one understanding. I'm gonna skip this part. Today, most of the big companies, when they simulate something with a computer, and when they see that it simulates human intelligence, even if it does not exactly imitate the way we are doing it in our brain, they consider we are going to take it because it's money wise. Okay? So one definition is there any utility to have such a program? You understand? If I say, for instance, talking back about this chair, having a robot that can bypass and recognize everything, does it recognize the chair as a chair, exactly as we imagine it? It's not important for a company as long as I can bypass the chair. You understand? So here it's not a way of simulating exactly how we imagine it in our brain. It's a question I turn. I'm not going to grasp the chair, etc. You understand? It's more an outcome. It's more, am I going to make money with it? And this is what companies today are using. So this is one definition. We follow the rationality of AI, okay, of the programs. Okay, if you see the history, of course, the machines, as I told you before, from the 20s till the 50s, no intelligence before. From the 50s, we have started to have some very low intelligence. I'm going to explain what is it. And then from this beginning of this century, a sort of revival and expansion of AI. Do you think why? I remember I started computer science and AI at the beginning of the 90s. No one was paying attention to us in our laboratories like it is today. Okay, why? Because it was mainly in academia. Okay, we were trying to do a lot of things, but we were not attracting people. We were not attracting businesses, etc. What was behind? Because do you know what happened in the beginning of the century? What exactly? Exactly. Internet revolutionized everything. It was the beginning of a new era because data have become available. Before, to be able to develop a model in AI, we were not in AI, data was not available, right? And that's why, and in addition, the computers become more powerful at the same time. That's why new companies appeared, what we call GAFAM. Do you know this word GAFAM? GAFAM, Google, Amazon, Facebook, Google, GAFAM, Google, Amazon, Facebook, I don't remember, and Microsoft at the end. Apple. So they are called GAFAM. So these big IT companies, because they know they can make money with it, right? With the data, and they were looking not to exactly imitate what's in our brain, but to have much to earn money. It was more rational and understanding exactly how it happens in our mind. Okay? Good. One of the key dates of AI is, for instance, 1997, where, do you know this guy, who is he? People from my generation may recognize him. Kasparov, yeah, from Russia, who was the world chess player, right? Um, but from 1997, IBM developed a machine that they call Deep Blue, and see with me, from that time, this machine is now who was able to win against Kasparov. And today, can you imagine, no other human being is able to win the machine. No other ones. Impossible. Any idea why? Any idea why you are not able to win the machine today?
Because the machine would basically encompass all the knowledge, all the skills from the different chess players, optimize it.
Okay, now you are using the new era of AI. It's a good point. However, how it was working of what we call, I'm going to explain. Have you ever played chess? Yeah. So when you play chess, when you have the counterpart, what you do, you try to imagine what the other player will play. And then, assuming he's going to move on the right, for instance, you say, what will be the best one for me? If I move left, then what he will do? How many steps can you imagine? How many what we call look ahead as human beings? How many look ahead can you do? 1, 2, 3, at most. Let's say 3, 4 at most, right? Deep Blue is able to do 13. It's possible to win, right? So that was, I'm going to go back to what the lady said. Yeah, that's the point. This is what you were mentioning before. Very recently, it's another play, it's another game named AlphaGo. right? And the machine was able to win, and the approach was different. I would like to introduce the approach. The approach was different here because the machine at the very beginning, this computer program was always losing against the world champion, right? But they changed the approach, and what they did, the machine, they developed a program where the machine played against itself many times, thousands, millions of times, and recording every time the machine loses. So next time it knows that if I go this side, and for every loss, they were tracking, they were recording the path. Understand? And with this, they understood that next time if I do this and that, I remember last time when I did it, I lost. You understand? And that's why this is what we call reinforcement learning today. Okay? Okay, it is applied also current AI in what is called natural language processing, in text processing. One of the key dates also is, I think it's 2005, where, in the US there is a game named, TV show named Jeopardy, right? And IBM developed a program named Watson. And Watson was able to win all the different players because this program was able to answer all the questions, like what we have today with almost LLM, with ChatGPT, but it was at the beginning of this century. Okay, we use it also in computer vision. We are able to recognize, remember the chair, recognize one item. We are able to recognize what is it. It's a car. Recognize the color, so on and so forth. So vision also is one of the fields. You have robotics. I would like here to mention something. When you see something, when we call robotics, it has nothing to do with AI, with computer science. Robotics is mainly mechanical engineering and electrical engineering. But once you put or you embed a chip inside, then you can have something that is intelligent, right? So robotics or intelligent robotics is when you add a computer within your hardware, right? Yeah. Yeah. Have you ever? So self-driving, right? Have you ever tested self-driving in UK? God, I don't understand, but I spent some months 3 years ago in the US, and I rented a car, and you are able to the car is able to self-drive. I was in the highway, and I drove the whole highway from New York to Washington for 4 hours, and the car was able. So it's not no more something that exists only in Google, etc. But it's, you see, recognize maybe the car. It's a very, it's a Honda. It's among the everyday cars that we are using today. You don't need this Google driver's car, etc. Okay, in the US today, it's among the everyday life, right? Yeah, I'm providing the YouTube, etc. So you can see that it's among the possibilities you have today.
10
Yeah.
minutes. 10 minutes.
Wow. I've not yet started.
Okay.
Okay,
I need to
quickly.
speed up.
Yeah, you can see also that, for instance, for the detection of cancer with dermatologists, it's very accurate. And I remember years ago I was making a presentation conference in a faculty of medicine, and some student came to me. Are we going to lose our job? I said maybe. Yeah. In some subfields of AI, computer science and AI is much more accurate than the human beings. Yeah, some concerns very important. Some people have been killed in the US because of the cars, the driverless cars. Okay, so that's why here it's a way to introduce ethics in AI. Who is responsible? One lady or one guy was killed by a car. Who is responsible for this? Yeah, I don't have to explain. I think you have bias. Someone is was guilty, accused by an algorithm. Who is responsible? And that's my base choice. You remember COVID, all of you, right? Can imagine that during the whole COVID, AI brought nothing. Nothing during 3 years of COVID. AI didn't help us in anything. So we are considering AI as something very, I don't know, but it didn't bring anything during COVID. So when you talk about LLM, AI, etc., question mark always. Okay? Yeah, and AI is very, it leads the world. You see, for instance, Putin who is saying whoever leads in AI will rule the world. We have big amounts of money all the Western countries are providing. Okay, quickly, let me talk now about the different approaches. Now, today, we are going to talk about LLMs, but you have other approaches that have existed in the past. Before, if you remember, no intelligence, we started with what is called rule-based. Remember that before 20th this century, no data was available. So what we were doing, taking the knowledge from the experts. We took the knowledge from human beings. And we had one, what is called knowledge engineer, to convert the knowledge it gives you to a using knowledge acquisition system to the knowledge rule, knowledge base. Okay, so you can imagine it was very time-consuming task, very tedious tasks, because not all the information is available. You have to meet the person, you have to do this and that, etc. But how these pioneers of computer science of AI started. It's a sort of like reasoning and problem solving. But of course, we were in need. We were lacking scalability. We were lacking flexibility in real-world scenarios. We were calling this closed-world environment because it worked exactly in this context. But once you move a little bit, it no longer works, right? So, but it was the beginning. So no data was available at that time. Now appeared what we call, you have already heard about machine learning, right? Machine learning, it's not LLM. What is learning? Machine learning. We were taking the data from any place. So let me this example. So we have a list of cities, you have temperatures, and you have the number of crimes. Can you see the relationship between these two? What can you say? Yeah?
Double the number.
Double, exactly. Exactly. Is it always exactly?
Not exactly.
Not, but more or
Near
less.
about.
Right. So we see the model is, statistically speaking, the outcome is double this feature. Okay. So the function becomes the violence crimes per day is exactly double the temperature you have. Okay. This is one example only to explain what is a model. So how can I model? If I give you tomorrow it's gonna be 9 degrees in London, how many cars are you gonna have? Yeah? 18? Are we sure? Are we 100% sure? We call it a prediction. That's why we call it a prediction, according to the model. Okay? But you can imagine, if I give this table more data, I'm going to have a more accurate model. Okay? The more data you have, the more accurate is your model. Okay? So this is machine learning, and machine learning is mainly statistics. Okay? For it is this one is very known. It we call linear regression. We put these elements within a figure, we plot them, and we try to imagine what line is it. Okay? and we call it, this is a model, and it becomes f of x. What is it? It's 2 times x, simply. We call it a model. Okay, remember this word model that I'm going to talk about later. So this is machine learning, but it's mainly statistics. We don't have only this model, you have different other models. After this, we witnessed at the beginning of 2000 in this century what is called deep learning. Deep learning tried to mimic, you know what is it? Exactly, a neuron in our brain, and you see the corresponding one in computer science. So you have input here, right? You have something happening in the middle, like this one, and then you have the output, okay? But inside, you still have mathematics. Is it more rational, or is it more mimicking human being, or human thinking? You remember the definition I gave you at the beginning? We have rationality. It's rationality because we're still having functions. Do you think we have functions inside our mind? We don't know. Who knows? We still need research to know exactly if we have functions inside. So that was the era of deep learning. These three guys from University of Toronto, from Facebook, and from the University of Montreal, these three guys won the Alan Turing Prize for the deep learning. And this guy, Geoffrey Hinton from University of Toronto, last year won the Nobel Prize in Physics, right? So deep learning was very important. It opened, so deep learning, because you have a sort of neural network looking like what we have in our brain, and you have calculations inside with inputs and outputs. And with this, we are able to do classification. You input for instance, a system with different images, and then you ask, what about these images? Are they birds or not? Because you train the system with this neuron, this network. These are birds, these are not birds. And it is able to classify whether it is bird or not after a while, right? This is why we call it deep learning, because we have what is called hidden layer in the middle. Right, so this is another model, and then came LLMs finally. What is LLM? LLM, it's a large-scale model. You remember I talked about model before? It was modeling only one system, the crimes with the temperature. With LLMs, data is so huge that you can have different models. The data is so big that you can train not only for having classification, crimes, etc., but you can, in the same model, have different tasks. You can do it now with ChatGPT. What can we do? Can we summarize? Yeah. Can we translate? Yeah. Can we do? Give me other tasks that you can do with LLMs. Paraphrase. Blah blah blah. So you have multiple tasks. Okay. Before, LLMs were able to do one model per task. Understand? One model for translation, one model for paraphrasing, one model. But with the huge amount of data that is available today, we put in the same model, in the same huge neural network, multiple tasks at the same time. Okay? ChatGPT looks like something like this, but a much huger one. A huge one. You understand? That is able to do multiple tasks at the same time. So that's ChatGPT, or the like, of course. So multiple tasks, excellent prediction, and it is good in generating the next element. Okay, that's the main point of what is an LLM. Okay, it has started to be done for only text, but now it is able to do it for images or other media. But the beginning was only for text. But we still have some limitations, of course, many limitations, and we can open the floor for this. Okay, see with me also very important. GPT-3 was trained on 45 terabytes. It's huge of text data after deduplication, because you can find sentences that are repeated, words that are repeated, so they take off the duplication, and after deduplication, they ended up with 45 terabytes. From where did they take the data? From the web. They scrapped everything from the web, everything for years, right? Capturing billions of web pages plus books, Wikipedia, scientific papers, news articles, and code repositories. With GitHub, for instance, that's now today we are able to generate code with ChatGPT. So this is the data that was trained from to be able to have ChatGPT. So what are the advantages? As I told you, it's a human-like text generation. So the main point of ChatGPT or LMs is text generation. The best probability of what is the next word after what you have written. You understand? That's the main point of it. Effective across multiple domains and languages. I'm going to tell you why right after this one. Leverage massive data sets to generalize effectively. Speed is very speedy, scalability also, and application. As I told you, you can use it for multiple tasks at the same time. However, what are the drawbacks? Lack of understanding. It doesn't understand anything, believe me. Doesn't understand. Right? It gives you the best word coming after. And after that word, it gives you the next one after that. You have the impression it understands. It understands nothing. It's stupid. Right? Of course, you still have bias and fairness. I'm going to tell you why. You know what is hallucination? Right? Great. Energy consumption. Let me give you one statistic. To be able to train one LLM today, only one LLM, they need energy for scrapping from the web. Then they train. The energy to do this process 4 months is equivalent to the energy consumed by a whole country like Nigeria for 1 year. Can you imagine? There is a problem about energy. This is what we, in general, we calculate the footprint, the carbon footprint, every time we develop a new LLM. We do have ethical concern, limited explainability, lack of domain expertise, a lot of money, and inability to handle real-time information. Today, if you ask ChatGPT, what's the next president of the US?
Elon Musk.
Maybe, but not,
That's the average
but not Trump. That is the next president, because it doesn't handle the new information. It has been trained in 21 ChatGPT, and it's open. Now, if you want to have another one, then you need to retrain everything from scratch. Okay, so they are unable to have always the updated version of it. Okay, I'm going to talk about the Arabic language, but to understand, these are. If you go to this website, you're going to find all over the world, the web, the internet in general, what's the content of it. You can see that, I'm sorry, background items. Can we take off this one? Yeah, 50% of what ChatGPT has been trained from is the English language. 50%, right? And then you have Spanish. Can you see the gap from 50 to 5? A huge gap, right? And then you have German, you have Japanese, you have blah, 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 etc. You can find what is Arabic language. And you can imagine many other languages. I mean, the gap is, you can, what to say also. So when you ask ChatGPT in Ukrainian language, for instance, the answer you're going to get, does it follow the Ukrainian culture or the English culture? Right? You have bias here. This is what we call bias. Because it's, let's say, English and Western biased. Okay? If you want to ask ChatGPT about anything. So those are the data that were used, because with zero dot, okay, I forgot to tell you that in some countries, some laboratories in Arabic countries, they try to have their own Arabic LLM, okay? And of course, with 0.6% of data, it's not enough to train and to have an LLM. So they were um, obliged to go in other data sets and try to train to have their own LLM. So we are suffering, apart from the English language, all other languages are suffering from the lack of data. This is one point. You can see that this is around the world, some countries trying to offer LLMs. One of the most advanced one is this one from Saudi Arabia. And there is other one from United Arab Emirates. What is JAIS, this one. There is a university in the UAE specialized in AI. The whole university does only AI, and they have their own LLM. So from my knowledge, these are the two main LLMs in the Arabic language. And they are not multilingual, they are monolingual. So this is just to give you an idea what other countries and other languages suffer from not having the data, where to train, etc. Finally, let's talk about ethics. To summarize, historically speaking, the first researcher talking about ethics is this guy, Isaac Asimov, who was a science fiction writer, who introduced the three laws of robotics. And you can see, not harm humans, obey to the orders, and protect themselves. And then he discovered that this is not enough, and he says this is insufficient in all scenarios. But the situation stayed the same until 2070s, where researchers met in AI conference, beneficial AI conference, to develop a set of AI ethical standards. That was the beginning of the ethics, right? Of course, now with science fiction movies, among others, it has increasingly reflected AI ethical concern. You can see the number of movies that you can see where you can imagine what are robots going to how to say, are they going to control all humans? Are they going, what will happen in the coming years with AI? Okay, this is one, if you are interested to read about the basics of AI, I would suggest this book, which is a sort of Bible of AI. Now we do have the 5th edition. It's really it's a sort of Bible of AI. And in this book, you can find that these guys, the authors, are proposing these 12 ethical principles for AI, right? And this is what most of researchers today are following. You have also a very known Stanford AI Index released every year. It contains many things about AI, what every country is doing, how they are performing, what are the research centers, so on and so forth. And you can see one is sort of study, yeah. The second one, they reported more than 260 incidents and controversies by only 2021. It's important to see that ethics is not respected, and we do have some incidents behind AI. Okay, and they are providing only 4 main ethical principles. For UK, we do have these 6 principles. With the these principles has been set by the British government and the Alan Turing Institute, and what they are offering also, they are offering a framework. I'm gonna explain. So the framework that they are proposing is called the British Process-Based Governance, published in partnership with the Alan Turing Institute, which aids British public sector organizations in applying ethics and safety principles to algorithmic systems. And they go through this framework to check whether the code they are developing, the software they are developing, whether it respects the ethics of AI. I had one. Yeah, I'm sorry. The last one is this one. Limitations. A significant gap in current AI ethical frameworks is the lack of consideration for culture and religious aspects. I can give you some very simple examples for culture and for religion. For instance, if you, for translation, for instance, I gave, if you ask about the idioms, have you ever tried the idioms to be translated? It never translates the idioms because it's culture dependent. Okay, I myself try to translate one expression in English. This was something warms my heart. Okay, but in our culture in Arabic we don't say. We say the opposite. Why? Because in our country it's very hot, and we say instead of this warms my heart, this cools my heart, which is the opposite. So it's really cultural independent, okay? And you can imagine also in terms of religion. In terms of religion, for instance, I know in Islam, for instance, it's forbidden to show the face of the prophet, okay? While in Christianity, you have movies that shows Jesus, for instance. So it depends on the, today, if you ask only any of the tools that can generate images, can you generate image showing the prophet of Islam? It gives you an image. Okay, so it does not respect the religions. I mean, it's most of the no, most of the LLMs today are Western oriented culture, and no religion is respected, no culture. I can give you multiple of examples behind all of this, and this is because, do you remember what's the reason? What's the reason? It's the 50% I told you before, okay? And now we are suffering from not having the digitized content of cultures, of religions, and written in all other languages around the world, okay? And also, I can tell you, do you have any idea what will come after LLMs? Any idea? Today, even in Alan Institute, in many other places in the world, laboratories, we're talking about symbolic, neurosymbolic AI, which is the next trend that will come after LLMs. LLMs is good, they are perfect. I'm using ChatGPT a lot, but I know where to use it and when to use it. I'm not using it for anything, okay? So you have to use it very wisely. That's my opinion, and it's not the end of the world. Something new is coming, okay, in near future, which today we are calling neurosymbolic AI. Thank you very much.
Thank you, Karin. Let's give Karin a round of applause. So, Karin, thank you for a very comprehensive introduction to AI. I don't know if there's any quick questions for Karin. Do you want to use it?
Sorry, kind of a joke thing. I mean, I did look up the next president on ChatGPT. It does says Donald Trump is president-elect, and then it gives information about the inauguration, but then it refers to different news resources. So it's getting better, as you said. It's developing every day.
Yeah.
Any other questions? Yes, easy.
I just have a quick one about how the models work and the difference between, because you mentioned deep learning and then into LLMs, and you talked about LLMs as being multiple models all performing, able to perform more than one task because it's models joined together, which made me wonder, so would you kind of think about, do you think it's helpful to think about as a kind of almost like a data frame of models, where there are all these models with access to different types of data? But then really my question is, so what's the parameter then? Because when people talk of a parameter, what would the parameter be within that?
So when you launch a model, you ask, today deep learning is very easy. I showed you one neural network, which is very easy, very simple. But in order to have this ChatGPT, you have not only 1, 2, 3, or 4, or hundreds, but you have billion of parameters. So in order to have these different tasks, you cannot have translation in addition to summarization, in addition to classification, blah, 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 etc. That's why it is necessary to ask to train for billion of parameters. You have, if you take the case of Llama, for instance, which is a Facebook LLM, you have different versions of Llama. If you take the easiest one, it's trained only on maybe 4 billion. If you take the next one, is trained on 25 billion, so on and so forth. Okay, and this, if you take the least one, I mean the basic one, it's not gonna do all the tasks you need. It's not gonna be as accurate as the others. And of course, if you want to have the others, it costs more. It consumes more energy. It takes more space. You cannot include it inside your machine. You need to do it on the cloud, so on and so forth. So everything, you have something to pay behind. Right.
You said at the very beginning you don't like LLMs or you don't agree with them. Does that mean you think they'll actually die out and be replaced by the new model that you suggested?
I mean, you mean the neurosymbolic AI?
Yeah.
Right. To be honest, I don't know. I want to. I have some ideas about neurosymbolic AI. I want to participate, but I think LM are here and they will still exist for a long time. So far, have no idea about how efficient symbolic AI is, but I think the LLMs. I mean, what I'm against, why I'm against LLMs, because simply it's the vibe behind. People are considering LLMs as something that does everything. It changes education, it changes our way of considering life, it changes everything. That's why I prefer to consider it for what it is good and no more. I'm using it for when I write my article, for instance, any paper, I'm using it, but wisely. I still need to have my own ideas in my paper and not its ideas, okay? That's why I need to see my input. It helps me in rephrasing, for instance, but I always double check. Sometimes, can you imagine that I was in coding, for instance, I tried two different LLMs, and in one of them, I developed a very small code. I give it to two LLMs, and one of them was not correct. So considering LLMs as what we call the ground truth, that's the problem. We humans, we should consider ourselves as the ground truth and not LLMs. This is very important, okay? Don't come, because can you imagine that among these 50%, the main content it has been trained from, what is it? Social media. Do you think what is said in social media is good? So, do you consider is it the ground truth? When you would like to have the ground truth, the knowledge for someone, you go to a professor, you go to a knowledgeable person, you don't go to anyone in the street. So now it's important to consider double check always. It can help you, but always double check and consider it good for what it is good and nothing more.
I'm going to be using my power as a chair to ask you the last question. So, I really like your last point over there about the current AI ethical frameworks that lack the considerations for cultural religious aspects. But what's the next step? How do we improve ethical frameworks? And is there any initiatives in, for instance, Morocco or any other countries, Arabic-speaking country, to address those challenges you mentioned?
Yeah. During the last months, I've been working with a group of people in London to propose a new ethical framework. Because so far I know only two. The one from the Allen Institute as a framework for companies, and another one proposed by Floridi. But it's more about the digital world. We have been working to propose a new framework that takes into account the religious aspects. We do have also, among the authors who are writing a paper, we have also a priest, because we say priest in English. Yeah, we do have a priest also. So we would like to bring, because the religion aspect is very simply to model, while culture is quite difficult to model. That's why we started from religion, because it's very simple to model, and we'd like to include some religious aspects in the ethical framework. How to make an advance also is to work um, towards the digitization of other languages. If you digitize other languages, you also digitize the culture of these other regions of the world. So it's important not to have only one or two languages, but we do have. There is a conference coming very soon in Paris where we talk about language technology for all. So we would like anyone on earth to be able to have access to the different services in its own language. So it's important to push towards this. We would like to digitize more content from all other languages, to have their cultures available there, and then to be able to train new LLMs specific to these other languages.